determine if there's any don't cares, or would they have to be like given the problem?
They would have to specify, somebody would have to tell you that those particular combinations of inputs are not possible. You'd have to know that. So we want to now take a look at implementing these things with gates, and we've already done that, right, with standard gates. Now, we're going to, I'm not sure if I'll do it next time, but we're going to start talking about the physical properties of gates and what makes them tick. What type of things, we talked about this briefly before, what kind of things can we use to be on, off, 0, 1? We use a switch, right? And pain in the neck, make a computer out of switches, all right? We could use transistors because they can be on and off. Can they be in other states? And the answer is, of course they can. They're a analog device, but you can use them as an amplifier. But we're going to use them in their all on, all off. 245, did you go through transistors? Yes? Okay. Yeah, maybe. All right, so transistor, we talked about a bipolar junction transistor. This is the base collector and the emitter. You should have talked about, and this is the collector current, the emitter current, the base current. All right. This is a NPN device. You talked about the different types of jump transistors. NPN, you saw this symbol someplace? Yes? Okay, what's the other symbol? It's the PNP. NPN, the little arrow is not pointing in. PNP, the little arrow is pointing in. It's the only difference here. Okay, and then the currents are going to be different. So your transistor is basically a current amplifier. I know we like to talk about voltage amplification, but these BJTs are current amplifiers. We can fudge things around in our analysis and assume that they're voltage amplifiers and keep our heads on straight, but they're really current amplifiers. You bias this guy here where there's a large voltage here with respect to here. If you don't put any current in, there is no current in the collector. You put a few electrons per second in here into the base, it gets amplified by this beta value here, or HFE sometimes it's called. And that's typically on the order of 100. So if you put 1 microamp worth of current into the base, you'll get 100 microamps worth of collector current. We've got a family of curves. So this is our collector current. This is the voltage collector to emitter. And this is the base current going up here. So this may be 0 microamps, 10 microamps, 20 microamps, 30 microamps, 40 microamps, something like that. Does that mean that you could not put in 35 microamps?
No, you just don't show that line.
You just don't show that line. Remember, this is a family of curves here, correct? And so we're just showing these, what would happen for step changes in the base current. If I told you that the beta was equal to 100, you come over here And what value of collector current do you end up with? Okay, apply this formula where beta is 100.
1,000 microamps.
1,000 microamps, which in most other terminology is called 1 milliamp, all right? 20 microamps in, you ought to get out 2 milliamps, all right? So we have what are called load lines. So if I were to put this transistor into this circuit here, we can draw a load line on this thing such that we could figure out what's the maximum collector to emitter voltage we'd ever have, and what's the maximum collector current. Okay. So if I told you that this was 5 volts, that RC was 1 k ohm, what is the maximum collector to emitter voltage? I'm not putting any current into the base. So can there be any collector current? No. If there's no collector current, is there any voltage drop across the collector resistor? No. So where's all the 5 volts have to be? Across this guy here. So that would be that point. If I drove so much current into the base that I saturate this thing and drive my collector to emitter voltage to 0, how much current is flowing? 5 volts here, 1 k resistor, no voltage between here and ground. How much current? 5 milliamps. So that would be my load line. Okay, this is where we're going to stop. I will send you via Canvas some homework. It will be under the files, so look for the homework for today under there, and that will be due in on Friday. The attendance sheet get around, everybody signed it.